So also, I like the approach, but it would be interesting to see how it compares with respect to accuracy and other parameters to the deep learning approaches. And this is what my previous colleague was asking also. And I think this is a very important question. And the second thing I wanted to remark is, could you comment on how does all this relates to security and data privacy? Thanks.
It is not at all related, sir. She put it in open issues, but here, not even that.
So this is not related to data security, but our health.
The conference theme is about security and privacy. So from that angle, professor is asking. Yeah.
Yeah, okay, Rajiv, go ahead.
Yeah, right. Ma'am, like, what is the resolution of the pixel? Like, how much bits you are allocating? The SAR image, I want to know about the, I mean, how many bits are used actually? Per pixel, what is the resolution?
Actually, it is a grayscale image, sir. Like,
grayscale, I can refer the grayscale by 3-bit, even a 4-bit or 8-bit. So
no,
what
0 to 255 8-bit resolution, sir.
Okay, 8-bit means I can say I can rank anything intensity, anything between 0 to 255. I'm right, ma'am?
Yes, sir.
So your variations are only 255 levels, not more than that, right?
Yes.
So now you're making this variations of 255 because into 3 different classes. One class is nothing, one class is huge variation, another one is the intermediate stuff. The variation, what I'm talking about, you have an actual image as well as the oil contaminated image. You are looking for the variations. You're taking the difference on that. The difference will be divided into 3 classes. Further, you're using a different mechanisms by taking the neighbors and all. You're doing that.
Yes, sir.
Okay. Right. So, see, like your major problem is like there are certain regions. It's very difficult to figure out exactly. So those regions mostly fall under the no change region because your scaling levels are very low. Scaling levels is like because you are discriminating with only 255. So if the discrimination is more, then you can do something on that. So that is a one vacuum I can thinking. Second thing is these images are bound to time variation. Let's say take the SAR image in the morning, afternoon, every 1 hour you apply your own strategy. I can say all are oil spill because like your algorithm will say that because like every hour there should be the change in the actual image to the 1 hour taken image. So when I apply your algorithm will change for the non-oil spill region as well oil spill as well. So that will happen. Could you agree this or not?
Yes, sir. That is like so when the sea is rough, if the sea state is rough, then it is going to become brighter, and if the sea state is very calm, the surface is going to be darker. That is why we are going for the neighborhood ratio operator and deep learning together.
Is it a ratio operator? I'm just asking, is it a ratio operator or only change operator? That's a different question I can come back to later on. Right. My question is, there is no oil spill as of now. There is no oil spill. The picture is taken on the same day with every 1 hour interval. What does your algorithm says? No oil spill, but the time of the image is captured in a different time. Like what is your algorithm will say for that?
Our algorithm is distinguishing, sir, because oil spill is giving.
Your aim is there is no actual data, right? You have to identify whether it is oil spill or not. Your input itself is a simple image. You can't get the images all the time with the oil spill and non-oil spill, right? So your algorithm will try to predict that. In that situation, you will get only the images from the satellites. You are getting the image. Then how do you sense it? Is there is any oil spill is happened? Because every 1 hour, if I take every half an hour, there should be the change on your own image itself on the same region of interest.
Every hour there will not be a change, sir. Only if the cyclone or some other weather conditions are changing, our sea surface, sea state is going to change, and we will be having different reflections, reflectivity of the ocean. So in that case, we will be our pixels will be falling on the intermediate class, neither changed nor unchanged. It will be falling on the intermediate class. At that time, we will be for those conditions we are going for deep learning based on.
No technical difference. I'm talking about feasibility level. I'm not going to the technical level right now. Only the feasibility level. Now, somebody want to defend on that. These are all this question for the open question. I'm just saying. So how do you solve that? Already people have done it on that. You just go and see again. And technically, like how do you give the ratio as an input to the neural network? This is a very important question. So you said that the ratio will be given. Usually, the categorical data will be given in a different way. Okay. So now the ratio. How do you give the ratio as an input to your neural network model?
The neighborhood ratio based change statistics, which are the nothing but which are the features.
Now, what is that exactly? Ratio means always, something will divide by something will come. How do you give that number to your neural network model? Could you get my question?
Yeah. Actually, the overall the mean of the image, how it is changing, that will be coming in the denominator, and the exact location, how it is correlating, that will be coming in the numerator.
Mean will leads to the different input exactly. Mean 1, 2, 3. I will get 2 as a mean.
Mean of the whole mean of the reflections of the image 1 and image 2. What is the correlation? That will become in the denominator.
Okay, I'm just suggesting these are all the excellent problems. Excellent problems, I can say. So without thinking about other one, I'm just thinking about like how do you give the fractions or ratio as the neural network model? So you just think on that. Okay.
Okay, sir.
You try to represent your change as a ratio in terms of some statistical value. Okay, don't think that. So instead, you just think it another way. Okay, because we have so many normalization, standardization method. If there is any method which could suitable for such kind of features to fit into the neural network, because that's a key point I could see from your presentation.
Okay, sir.
So fine from my side, yeah.
Thank you.
Thank you. Tamu, you are on mute.
Thank you, ma'am, for presentation. I hope that you will, whatever possible, the comments, what they have given, please try to incorporate in the paper. And you can resubmit that. I now thank the session chairs for sharing your knowledge to the participants. I hope that the session was useful for all the people who participated. Thank you, Dr. Ulrich, Dr. Chitra Babu, ma'am, and Dr. Rajesh Kanas. Thank you.
Thank you. Thank you.
Bye-bye.
Bye.
Thank you, everyone. Now the time for paper presentation session 2. For this session, paper ID 28 and 30 participants, be ready with your presentation. And I would like to welcome our session coordinator, Dr. J. Sureshar, Associate Professor, CSC Department, SSN College of Engineering. Sir, please take over the session, sir.
Okay, ma'am. Okay, ma'am. Thank you. Thank you very much.
Thank you.
Actually, for this session, 2 papers will be presented. Paper ID 28 and 30. And paper ID 28 is time efficient symmetric key encryption technique for ECG waveforms. Authors are Pooja Premnath, Sanjay Balaji, Prahalad, Chamandeshwari, and Dabu Suman. Actually, who is going to present? for this paper? Presenter will be?
Sir, Pooja, Prahlad, and Sanjay, the three of us will be presenting. Sanjay will be sharing the PPT on his screen.
Okay, and then another paper, paper 30, Proposal of Effective Financial Fraud Detection by Adumu Husaini, Zahia Gusom, Unica Laurent, and Dominic. And I don't see the authors.
No.
Sanjay Balaji, you just wait for some time because the session chairs has yet to arrive, and Prasad sir and Sanjit from IIITDM and
Gauri Ganesh.
Gauri Ganesh from Savita Engineering College.
Okay, sir.
So two just session chairs joined, Prasad sir and Gauri Ganesh, but Sanjit from IIITDM, Sanjit Kumar Nayak from IIITDM. So Dominic sir, are you there? Dominic? The Prasad sir and Gauri Ganesh sir.
Hello, sir.
Hello sir. Sir,
Good evening.
just
Good evening.
switch
Good
on
afternoon.
your video sir, so that we can see you after a long time.
Okay. Yes, sir.
Prasad sir, your video is also. So, sir, shall we start, sir, or shall we wait for Sanjit Kumar and I?
Can ask Chamu madam.
Okay, sir. Wait, just I will call her. Actually, two papers are there, sir.
Okay.
One paper is from France.
Okay.
And actually, author is his author name is Adumu Hussaini, and the co-author is Dominic. But Dominic sir is here, but he is not going to present it. Adumu will be presenting. So we informed Dominic. And the second paper is Sanjay Balaji from SSN College. Co-author is Chamundeshwari ma'am. So this paper, second paper, will be presented by Sanjay Balaji and Pooja Prahalad. So two persons are here. And
Shall we start, sir?
actually, I called Chamundeshwari ma'am. She told that she will be calling Sanjay. So just I am waiting for her call.
Okay.
And also the second paper, Adumu has to join. Actually, she informed Dominic. So
Okay.
we will start, sir. When they come, we will get it.
Yeah, fine.
Sanjay Balaji and Prahalad. Sanjay Balaji and Prahalad.
Yes, sir.
Actually, the
Yes, sir. I'll start
time allotment is 10 minutes presentation and 5 minutes question answer, right? And at least one person is enough to present. Don't switch over among yourself. One is enough. Either Sanjay Balaji or Prahalad is more than enough. So one can present it. So both the Prahalad and Sanjay, you can answer the questions. Who is going to present? Once again.
Pooja is presenting, sir.
Sir, is our screen visible?
Presentation mode.
Sir, is it fine now?
No, it is not in a presentation mode.
It is not? Okay, give me a second.
So the second person, paper number, paper ID 38.
Yes, I'm in the
Adumu
meeting.
Adumu Hussaini has joined. So just you wait, sir. After 15 minutes, you can present. Adumu.
Okay.
Prahalad or Sanjay Balaji, you can present.
Sir, is it visible now?
No, it is not as a presentation mode.
It still isn't. Okay, give us a second.
Just
please.
enable editing and then do it.
What about now, sir?
I guess, yes.
Okay. Good afternoon. My name is Pooja Premnath. I'm a second year undergraduate computer science student at SSN College of Engineering. Today, along with me, my project partners are Sanjay Balaji and Prahlad. Our project guide is Dr. Chamundeshwari from the computer science department. Today, our paper deals with the time-efficient symmetric key encryption technique for ECG waveforms. Before I introduce our paper, I'd like to give a brief introduction about the need to encrypt medical data. Medical data is very sensitive in the first place, and patient records always need to have a high level of security and confidentiality surrounding them. According to HIPAA, the Health Insurance Portability and Accountability Act, it's necessary to protect sensitive patient health information from being disclosed without the patient's consent or knowledge. Some of the most basic violations of HIPAA include the lack of encryption of records, and the lack of encryption would thereby lead to hacking and phishing as well. Even providing unauthorized access to medical data is strictly prohibited. This means that all medical data has to be encrypted in a secure fashion. Um, HIPAA requires, as I mentioned, it requires the encryption of protected health information, either when it's in the printed format as well as in its electronic form on a hard disk or a USB. And even when medical data is transmitted from one medical facility to another, it has to be in an encrypted fashion. Our problem today deals with encrypting ECG waveforms. There are other solutions which encrypt ECG waveforms, but when we were looking across them, a lot of them are very inefficient. A lot of the ECG waveform generally is in the form of a wave file, and the most commonly used technique that we discovered is that that matrix operations are used on the waveform. The matrix represents all the amplitude values of the ECG, and the size of the matrix is captured and then it's converted into a column matrix. In order to carry out any kind of matrix operation, it has to be a square matrix. So zeros have to be padded. Zeros are padded to make the column matrix square so that it can be utilized for further matrix operations. However, what happens here is that when the size of the data becomes very large, the number of zeros that you'll have to pad to make the matrix square becomes so huge that any kind of computation becomes very difficult. Therefore, there is a need to derive less computationally intensive and more time efficient techniques to generate square matrices and thereby encrypt them. And today our paper focuses on developing a method such that the time taken for encryption and decryption using matrices drastically reduces. The data that we've taken comes from the MIT BIH arrhythmia database. It has ambulatory ECG recordings, and each recording is around 30 minutes. The nature of the file is a wave file. It's a stereo wave file, meaning it contains two channels. The record that we've taken contains 650,000 rows of amplitude values, and there are two columns of that, so it leads to almost 13 lakh values in all. Before I talk about encrypting or even optimizing the process of encryption, I'd like to talk about the overall structure of ECG waveforms. Basically, an ECG is an electrocardiogram. It's a tool used to record electrical signals from the heart. It can check abnormalities and can find out if a person has underlying heart conditions. And in order to take readings for an ECG, electrodes are placed on the chest and electrical activity is monitored. ECG setups largely vary. There are different number of leads. There can be 2 leads or it can go all the way up to 12. For a 2-lead ECG, there are two kinds. There are limb leads and precordial leads, wherein limb leads monitor the electrical activity of a heart along the vertical plane, whereas precordial leads monitor the heart conditions across the horizontal plane. A very basic waveform is shown in the picture, and it has some components, the PQR, PT, and the QRS complex. The P and T are relatively low in terms of frequency of oscillation, whereas the QRS complex has a peak and it has a high frequency of oscillation. As I mentioned before, there are different systems which exist, but then the most important thing is to find a balance between a good method of encryption versus, and it should also be less computationally intensive. It should take less time. As I said, many symmetric key techniques use matrices, and as mentioned before, as the size of the file increases, matrix operations become exceedingly complex. The existing solutions are as follows. The wave file is initially made in the form of an n-cross-1 matrix, and as I said, since most operations work on square matrices, it means that n-cross-1 has to be made into an n-cross-n matrix. We tested some existing methods on the MIT BH arrhythmia database records, and we found that whenever the ECG recordings become around half an hour, the entire process of encryption and decryption is very slow. It takes around 15 minutes. And thus we propose a method to make the entire system less time consuming and more computationally and less computationally complex. Our methodology is as follows. We first read the ECG waveform, we reshape it into a single channel from the stereo format, and we also need to reduce the size of the matrix. It is done by finding the most optimal combination of rows and columns, and we pad only the minimum number of zeros that are required. We generate a random key, multiply it with the reshaped matrix, and get an encrypted waveform. We also decrypt it to check the similarity between the decrypted and the original waveform, and finally we apply some evaluation metrics to test our overall strategy. We've used the following tools. We've used MATLAB predominantly because we are dealing with very large matrices. We also analyze data using Jupyter Notebook, Pandas, and NumPy. And for visualizing the plots, we've used Matplotlib and CB. The preliminary analysis of the ECG waveform is as follows. The different signals are captured from different portions of the chest, and ours is a two-channel ECG waveform, and each channel represents a differential voltage between two electrodes. When we first read the ECG data, it looks like this. These are the first 10 seconds. Here, the red line represents channel 1 and the blue line represents channel 2. The next thing that has to be done is to concatenate both of those channels in order to make a single channel. So the total file has 650,000 rows, and concatenating it would become over 13 lakh rows. So if this is the two-channel matrix that we have, it is concatenated into a single channel. The next thing is to find the dimension of the matrix which has the most optimal size. Let's take a very simple example. If our audio file has 15 rows and 2 columns, then the first step is to concatenate it into a 30 cross 1 matrix. In order to find the optimal size, there are different combinations of rows and values that are possible. For example, you could have a 10 cross 3 matrix or a 30 cross 1 matrix or even a 6 cross 5 matrix. The dimensions which require the least number of zeros to be padded, that is the optimal size. For the given example, the dimension 6 cross 5 would be the most suitable, and minimum zeros would have to be padded. You'd have to pad only 6 zeros, whereas in existing techniques wherein you pad like n minus 1 columns of zeros, then around 841 zeros would have to be padded. Here in this technique, only 6 zeros would have to be padded. Considering a very large data set like the MIT BIH data set, the reduction in the number of zeros that would have to be padded is drastic. With existing methods, the number of zeros that would have to be padded is the huge number there, which is incredibly difficult to compute, to perform operations on. Whereas with this proposed methodology, the number of zeros that have to be padded would become 262,500, which drastically reduces the size of the matrix. The technique that we are building upon is symmetric key encryption. It's a very simple technique wherein there's only a single key, and this key is kept secret from third party. It's a very simple method to encrypt the ECG. Now that we've arrived at the size of the square matrix, which requires the least number of zeros to be padded, we do generate a random key matrix, and that is multiplied to get the encrypted matrix. As you can see, this is the original versus the encrypted waveform. The original one is on top, and the encrypted one is as shown below. The next thing is we also need to check whether we get the original matrix and the original values after decrypting the waveform. To decrypt it, we compute the inverse of the matrix, inverse of the key matrix that we have. Note that the process of finding the inverse is much more easier since the size of our matrix is much smaller due to us optimizing the size of the matrix. This would lead to the decrypted matrix. Even after obtaining the decrypted matrix, it is required that we strip the zeros that we padded before, and thereby we get the optimal matrix dimensions. The original data is a stereo wave file, so we reshape the matrix back into its original format. The most important part of our paper deals with the time taken to encrypt and decrypt. In previous situations, in order to encrypt and decrypt the MIT BIH records, on an average, it takes 7.4 seconds to encrypt, around 35 seconds to decrypt. However, after reduction of the matrix size, the time taken to encrypt and decrypt becomes very negligible. In order to compute efficiency, we tried it on a 10-second sample because for doing it for the entire 30-minute record set, it took over 15 to 20 minutes. We also need to evaluate the efficiency of our solution. We've proposed a couple of methods that can be used. We can measure the effectiveness of encryption using a histogram, and the mean square error is also computed to find the differences between the original and encrypted waveform. The structural similarity of the original encrypted waveform is found out to see how similar the original and the encrypted waveform are. The first metric that we use is a histogram. Histogram help us measure how robust the systems are against attacks. So the more normal the distribution, the better is the technique of encryption. As you can see on the right, the distribution of our encrypted amplitude values, the probability distribution of it is nearly normal. The next thing that we use is we compute the mean square error. This graph, the red lines show the original values, whereas the black dots seen on it are the deviations. And as you can see, the deviations are very minute, meaning that our process of encryption and decryption leads us to getting the original waveform back. The next technique that is used is structural similarity. Structural similarity helps us find out how similar the waveform's original and encrypted values are. And an SSIM, that is structural similarity index of 1, means that the encrypted and the original waveforms are exactly identical to each other. Whereas if you had a value of 0, it means that structural similarity between the two is very different. It is better that the original and the encrypted waveform look more drastically different from each other. That is, the value should be closer to 1 than it is closer to 0. So the structural similarity of our technique comes out to be around 0.6. I'd like to present the results that we've come up with after analyzing the ECG waveform. This technique that we've utilized comes for a much simpler method. The overall reduction of the size of the matrix drastically reduces the time that it takes to encrypt and decrypt the matrix. It's also a method where the margin of error is very slim, meaning that the original waveform is preserved. As we saw in the histogram, the distribution of the encrypted values is a normal distribution, meaning that the system is quite robust. And as mentioned before, the most important part, the time taken drastically reduces. So thank you for letting us present. Thank you very much.
Thank you, Pooja. So, I welcome Dr. Sanjit Kumar. Actually, he just joined. So, any questions, sir? This is the first paper.
Yes. Okay. Am I audible, sir?
Yes, sir. Audible, sir.
Yeah. Okay. So I think the presenter name is Pooja or
Pooja Premnath, sir.
Yeah. Okay. Okay. So Pooja, it's a good presentation and work. Okay. So though I joined after 2-3 slides, I have one or two questions. Like one thing I observed that the encryption time and decryption time is not same. I mean, why so?
The encryption sir, the time taken for encryption and decryption is not the same because the process of encryption is mere matrix multiplication, whereas the process of decryption involves computing the inverse of the key matrix and then performing matrix multiplication. And the process of inverse computation is generally a little bit more complex than matrix multiplication. So that's why there is a difference in time, sir.
No, but the inverse of the key you need to generate only once, right? Not every time.
Yes, sir. It needs to be generated only once, but then the decryption process consists of two steps. Both the generation of the inverse, that the inverse is what takes up most of the time, and then multiplying that with the decrypted thing is a secondary process. So decryption is two processes in itself. So that is why there is a time lag there.
Okay. No, so what I'm trying to say is like for encryption, you need a key, and the same key you are sharing to the other party who will decrypt in future, right? So,
Yes, sir.
so the person who is decrypting, he can calculate the inverse of the key on prior to doing the decryption process, and then I think
Yes, sir.
the time will be almost same. You can save some amount of time there because it
Yes,
is a one
that's true.
process, right? So you can
Yes,
save
sir.
some.
If we,
Yeah.
yes, sir.
Okay, fine. And somewhere you mentioned that you are generating the key randomly. I mean, why so? I think in
The
some you mentioned why random key need to be generated, why it is required.
So it is, we multiply the original matrix with the random key, sir. So the values should be random because otherwise it would become much more easier.
And how did you generate that
So
random key?
they are decimal values that we've used because if we were to follow some
No,
systematic
no,
pattern in generation of the
no,
key,
no. What I am saying
then
is, yeah, Pooja. What I am saying is, you wrote some code, right, for
yes,
this.
yes, sir.
So how do you generate random key?
Sir, the randomness that you mean the key values, sir, that we've generated.
Yeah, yeah.
We chose key values. We chose double values randomly, sir. That's the only thing because we thought that if we followed any kind of order in generating the key, then there is a probability that it could be cracked. But here, if you generate a completely random system, then when you have a matrix of such large size, finding out each of those decimal values becomes very difficult.
Okay, fine. So that I mean, you are talking about brute force kind of attack, right?
Sir, yeah.
Okay. So any other attack did you try on the scheme? Any other kind of security analysis apart from this?
Sir, you mean a different technique to encrypt
Different
the...
kind of attacks, like there are replay attack is possible. Okay, man, the middle attack. So different kinds of attacks are possible. So did you check those attack on the schemes, whether your scheme withstand that or?
Sir, we've tried only on the most basic of schemes,
Okay.
sir. We were more focused
Okay.
on
Yeah, it's
making
good.
system.
Maybe future you can try. Okay.
Yes, sir, we try that.
Okay, fine. And last questions that I have is, see this matrix you are changing, no, from matrix having two columns to matrix having one column. Is it so?
Yes.
This is what you are trying, right? So then how you are doing? So for first channel you are writing, then for second channel, is it? I mean, how you are converting the matrix? Yeah. Hello.
Hello, Pooja Premnath?
Yes, sir.
Yeah.
Answer
So
the
how
question.
you are doing that?
Pooja, can you open that slide and you show? You have a slide.
Yes, sir. Yes, ma'am. So you mean this like?
Yeah, yeah. How you are doing that?
Sir, it is mere concatenation of the two column into a single column matrix, sir, because the nature of the ECG file that we received is of a two-channel format. So that is converted into a single channel. It's mere concatenation of one below the other, and after we decrypt it, we do take it back to the two-channel format.
Okay, and the receiver knows that the first channel data is present in the first few rows. Is it so?
Yes. Yes, sir.
Okay. And how do you communicate that information to the receiver? Because receiver doesn't know, right? Because this, along with the key, this information also you need to tell, isn't it?
Yes, sir. That is true.
So how do you communicate this information to the receiver? So along with the key, or I mean, when you will send this thing?
Along with the key, the fact that we are concatenating it also has to be passed along, sir.
Okay. So if you will change this order also, then it will not work, right? So therefore, this also you need to communicate.
Yes.
Okay, fine.
Yes, sir.
Okay, fine. Yeah. So that's it from my side, Suresh sir.
Yes, sir. Okay, sir. Sir, Gauri Ganesh, sir? Or Prasad, sir?
Hello.
Hello, sir.
This is my question. Like, whenever you look into for this security aspect, the first thing is like, what is the time taken for? Have you checked this? What is the time taken for breaking your system? You had checked for time taken for the encryption, right?
Yes, sir.
What is the time taken for breaking your system? And why have you checked whether any of the techniques that you had, if you had applied for this instead of symmetric, your encryption technique? So have you tried out any other technique? Yeah. Time
Sir,
taken. My question is time taken for breaking your system.
Time taken for breaking the system. Sir, we tried out only the most very basic.
Yes.
That is one flaw that we have to admit, but we haven't tried it on like very strong attacks, so I wouldn't be able to tell you the exact time that more complicated attacks take. And in terms of sir, in terms of other techniques that we possibly looked at, we looked at steganographic techniques as well. That also seems to work, but then it seemed as an unnecessary addition to this, so we did not really include that.
Yeah, it's fine. Just I just want to know that because whenever we look into the security system, we need to know how quickly we are able to break up the system. Okay, because when you do this, you are telling that it is very means you are able to reduce the time. Okay, while sending, this will be sending through the network, right? So while sending through the network, it is quite, you have to understand that what is the time taken for breaking the system, because it travels through the network for a long time, and it is quite possible that any intruder can quickly break in your system, and then they can take up the data. Your ultimate aim is to not to hack the data, right?
Yes, sir. That's true.
Yes. Okay. So in the case of ECG, that data set that you had taken is 2 channels.
Yes.
Is there any possibility of having multi channels?
Yes, sir. As ECG can have anywhere between 2 and 12 channels. The data set that we have has 2 channels, but the method that we use would work no matter the number of channels that we take.
Okay. Whether your system, your system can scale up when your channels grow up, whether
Yes,
it is
sir. Yes, sir. It'll work on 12 channels as well, because the previously existing systems, if you tried to handle 12 channel data, computation would become very difficult. But then with our system, 12 channel data would work.
But that do you have the result of that?
No, sir.
For
We
the
have not
multi
tapped.
channels.
No, sir. The
But you cannot confirm on it.
Yes, sir.
You cannot confirm on it, right?
Sir, the technique would work, but the time taken, we do not have the readings of that.
I think so. It may differ also. Okay. Okay. Let it be. That's all from my side. Thank you.
Okay. Prasad sir, any questions sir, from your side?
Yeah. Have you compared your results with any standard benchmark results in the same work?
Sir, a lot of techniques that exist before, as mentioned, the time taken is very large. So our basic metric of comparison is the time taken, sir. So while other data sets take several minutes to run, ours takes only a couple of seconds. That was our predominant focus.
So your method will reduce the time, right?
Yes. Yes, sir.
So what is the time complexity of your algorithm?
Sir, the time complexity.
Yeah.
As a big O.
Order of what?
Order of what?
Sir, the order is.
No, you just calculate it from your algorithm and then you have to tell that one.
Sir, since
Okay, ma, fine. Yeah, you can do it later. Yeah. Yeah. Okay, fine. You can. That's all from my side.
Okay. So Pooja, actually note this correction. Actually, you have to compare your work with other available works. For example, instead of going for a symmetric encryption, you can use autoencoder also.
Yes, sir.
So just compare your results with autoencoder.
Yes, sir.
So at present, your paper, there will not be any comparison, I think.
No,
You have
sir,
not done any comparison. So just try to compare with autoencoders. So where you are bringing the neural network concepts.
Yes,
That one. And then you have to include that big O value also.
Yes, sir.
Complexity. Huh?
Okay.
Okay. Thank you. Thank you.
Yes.
Thank you.
Thank you very much, sir.
So the next paper will be proposal of effective financial fraud detection system by Adamu Hussaini. They are from France, and they work in Christic Laboratory. And I call upon Adamu Hussaini.
Yes,
Are
sir.
you there? Ah,
Yes, sir.
just can you share your screen and presentation?
Okay, thank you.
So the presentation time is 10 minutes and question hour is 5 minutes.
Okay, thank you.
Okay, okay.
Okay, good afternoon, everyone. My name is Adamu Hussaini. I'm a PhD student at Crestic Laboratory under University of France in France. My supervisors are Professor Zahia and Professor Unica. So my PhD thesis is treating the problem of financial fraud with artificial intelligence techniques. And we are working on machine learning techniques and knowledge-based techniques. In this paper, I present the proposal of an effective financial fraud detection system that will be focused on knowledge-based techniques and ontology-based. So in this presentation, I will talk about the introduction of the work, the research challenge, and some existing works. And I will also describe our main ontology, like our knowledge-based ontology. We will discuss about the system architecture, which include the phishing scenario that we treat in this paper, and also some detection rules that we proposed, the inference engines, then discussions and the future work. So in the introduction, financial fraud detection is becoming more and more challenging for organizations, for businesses, and even for government. So fraud is very economically challenging because it is dynamic. The fraudsters are very dynamic. They change from one system to another. Once we invent a system that can counter their measures, they dynamically move to another method. So they are very creative. So and also detection and prevention of this fraud present a complex challenge that is relevant to many academic disciplines. We have seen so many fraud detection approaches from various academic disciplines. So some of the research challenge that we faced in our in the entire research process is that the approach must be able to provide judgment and alert for the user for a possible identity theft, which is a main class of phishing fraud in a user bank account. And also the research noted a possible change of behavior, as I described earlier, from the proud stars. Also, the semantic learning and updating of the proud rules is implemented in the system, so that we must implement a learning procedure for the system to learn a dynamic change in the proud stars behavior, as well as the user behavior. And also the analysis of the existing works, the impact and shortcoming of those existing works, so that we can implement a better system. So in this, let me talk a bit about the financial fraud detection system ontology that we proposed before this paper. We have proposed a financial fraud ontology that will serve as a knowledge base to our proposed detection approach. So this ontology is based on financial fraud. It's a financial fraud ontology. And also it can, it represents knowledge, and also it represents an extraction of knowledge from different sources. And we also created terminologies or axioms for in the ontology. We also classified the ontology into different domains, including the concept, the individual, and the properties. And we also have some semantic annotations and their relations in the ontology. So we developed the ontology using a Protege ontology development software that is in ontology development language all. There are several related work for financial fraud and other fraud detection approach that have been implemented in ontology. Some of them are a work by Mansour that they focus on sending alert to the user once a rule-based ontology detection system that send alert to the user once there is unusual behavior or unusual activity in his account. So the user, the others, they use a richer domain sources whereby they form a knowledge base which contains all the user's behaviors, and they annotate each behavior with a possible change. So once the algorithm noted a change in the behavior, it generates an alert and sent to the user for verification. Another fraud detection approach with ontology is a money laundering ontology base. That this approach, it serves as a knowledge base for all the possible money laundering approaches or circulation. So it gives a knowledge of money laundering activities, from placing knowledge to circulation of the money knowledge to the integration. Hello? Hello?
You can skip this part, related works. You just explain what you have done.
Okay. Okay. So our proposed system consists of several components that include the ontology, the one that I described earlier, the detection rules, the inference engine, and also the SpyQL query. So we have a phishing fraud scenario whereby we assume that an attacker send a phishing email to the user, and the user clicked the phishing email. So the attacker received the user details and tried to perform an activity in the user account. So what we did was propose a detection rules. There are various detection rules that we propose using an Apache Jena semantic web toolkit, that we write the rules that using several knowledge we extracted from our main ontology, that is the fraud ontology. So these rules will tell, we set the rules based on the knowledge we extracted from the fraud ontology. And some of the rules that we propose, as example here, we see like if the browser has IP or the IP is not visible, then the inference engine will make the decision. And if the device of the user is known, then the device where the inference engine will make the decision to accept. If it is not known by the system, then the inference engine will decide to generate send a verification to the user to verify if he is using another device to access his account. And some of these rules we generated have been accepted, have to be passed through the inference engine. So how do we query the ontology to give us from the system? How do we query the ontology is we write some ontology SparkQL query. There are some existing SparkQL query, but we extended them so that we can query the ontology. The user can query the ontology. An expert can query the ontology based on suspicious activities. Okay, so let me just go here. So in this proposed approach, we try to solve to prevent an unauthorized activity in a user account by detecting some unusual behavior based on the knowledge we extracted from our already existing ontology that we built, that is fraud ontology. So, and to see that if there is a breach in the rule, and if there is a breach, we generate a verification. And then if the user confirms that the activity is unauthorized, then we blacklisted the device that tried to perform the unauthorized activity. So also in this work, we are going to implement some possible future work, which one of them is expanding the work not just on phishing detection to other various financial fraud activities. As we have it in our fraud ontology, we have so many fraud detection knowledge, including banking, tax fraud, telecommunication fraud, and other form of identity theft fraud. Also, we are going to propose an interface, user interface that include a main taxonomies and also main activities of and characteristic of fraudsters. This user interface can serve as a knowledge, ontological knowledge interface for users. And also we are going to compare those works that we are going to propose in the future with other machine learning approach for fraud detection. Okay, thank you.
So question, sir.
Okay.
Okay. So, hello, Adamu, can you hear me?
Yes, I can hear you. Yes.
Okay, fine. Okay, nice presentation. So this is, I think, you are starting a work, right? So basically, in future, yeah, you are going to propose some technique in which you are going to, I mean, give a demonstration how to prevent the frauds, right? So, and you are saying that you will do it using machine learning techniques, isn't it?
Okay, yeah, we are going to compare this approach with some other existing machine learning techniques. Okay. After it is it has been implemented. Yes.
Correct. So is there any requirement of data set for you? I mean, from where you will get the data set?
Yes, so there is a process of validating this approach, and we need a data set, and to compare or to validate this approach. So in this, the data set must be from, we already have some data sets, but we can only use it when the system is has been developed and we see the result of the performance. So we can compare with the with the proud data set. For example, we can use a banking proud data set to see the how many proud, if our system can be able to classify a proud that has already been classified in that particular data set.
Okay. Okay. So then this method that you are going to build, it will be a supervised or unsupervised method?
No, it is unsupervised method because it will be able to learn from we have a knowledge base already, a proud ontology. So the system should be able to semantically learn from the detected activities and update the rules. So once a prod has been identified, then the system should be able to update the rules that are in the inference engine.
Okay. So basically, I mean, using the previous previous bank fraud data, so you will predict in future, right? That is what you are trying to do, or you will detect if the fraud has happened?
No, it will be the use of the data set is just to see the performance of our approach so that we can validate it and say the approach is good. So our approach will detect some, for example, we will have a patient, we have a patient proud detection rules. So based on the performance of our rules, we are going to compare it with another patient detection data set to see if what our rules detected have similarity with the ones in the data set.
Okay. So have you done any implementation of this work or just the proposal?
So previously we tested some scenarios, as I said, a phishing scenario, and the rules are able to detect some activities, unauthorized activities. The rules we proposed were able to block and some activities, but the learning approaches for the rules to update itself and has not been implemented.
Okay. Okay, fine. Thank you, Adam, for
Okay,
all
thank
this.
you. Thank you.
Yes, Suresh
Okay,
sir,
sir.
that's
Okay, sir. So, Gauri Ganesh, sir, any questions from your side?
Hello, Adam. What is the
Hello.
scope of the financial? Hello, are you able to hear?
Yes, I can hear you.
Hello. Yeah, yeah. What is the scope of the financial fraud that you had selected for deriving the ontology?
Okay, the code there in here in this proposed approach, we only consider identity theft. So we classified the financial fraud into various domains, about 11 domains, including banking fraud, identity theft, tax fraud, insurance, telecommunication fraud, and so on. So we picked in this proposed approach, we picked and all these classes, they have subclasses. We classified into various subclasses. For example, in banking fraud, it has subclasses of credit card fraud, money laundering, debit card fraud, and so on. And under identity theft class, we classified it into various subclasses of phishing fraud, email fraud, and other fraud. So in this proposed approach, we tested a scenario of phishing fraud, which is a subclass in identity theft.
Okay. How did you evaluated this?
Okay, so we there are, as I said, there are some existing ontologies, and to evaluate and classify all this fraud and the knowledge in the of classification the fraud, we use there is an existing ontology which is a generic fraud ontology. So we obtain the layers of classification from that ontology. That is, we reused the layers of this classification from that particular ontology.
Have you taken any instance or something like that? How you had done this?
Okay, so for example, on that particular ontology, the authors, they classified it into generic, domain, and case specific fraud. So in our ontology, we also classified it as financial fraud is generic layer, and then other classes, like as I said, banking fraud and identity theft, are domain specific layers. And then subclasses like phishing fraud, like credit card fraud, like money laundering, are case specific layers. So these layers, these subclasses and all the classes, they also have their, I also introduced their properties, their object properties and their data properties. It is all in the ontology. So we extract this knowledge from the relations between all the properties. We extract the knowledge between all the subclasses and their classes to have a particular behavior characteristic or characteristics of how that particular fraud is being achieved by the fraudsters.
Have you used any Spark SQL, something like that, to query your this thing?
Okay, so in the ProtoJS ontology development software, there is a query. There are so many query options to query the ontology to see the knowledge. So I used a SparkQL query to, it is an inbuilt query option in the development software that you can query the ontology. So I use SparkQL query to query some of the knowledge in the ontology.
Yes, but I couldn't see anything from your slide about that query and the answer. So that's why I had asked this question.
Okay, yeah, because this the ontology I was talking about is like the main ontology, the knowledge base. Here, our proposed approach is like a particular scenario that we picked to use the knowledge in the main prod ontology and implement a detection approach.
Yeah, that's fine, but at least a minimum evaluation, I think this querying technique should have been applied. That is my opinion.
Okay,
That's fine.
yes, sure. Okay, thank you.
Yeah, thank you. That's all.
So, Prasad sir, any questions, sir?
Yeah, okay. How AI can be used to detect for banking frauds?
Hello?
How artificial intelligence can be used to detect banking frauds?
Okay, so the approach or the scenario of banking fraud have not been implemented, but we have all the characteristic of banking fraud. For example, we have various approaches that the fraudsters used to perform a banking fraud activity. For example, ATM machine fraud, how the fraudsters are able to put some chips or to manipulate the user ATM or users whenever they try to use our ATM machine. We also have credit card fraud. That is a form of that is subclass in banking fraud. We also have all the characteristics that the users or the fraudsters are used to perform such a criminal act. So we are going to implement a rules that will be able to send an alert to the users whenever, for example, a fraudster steal your credit card details, and you are in India and the fraudster is possibly in France or England or somewhere else. So we are going to implement a rules with the banking data to see user data to see that if your last activity, the location of your last activity or the time of your last activity, and also the activity that is proposed by the fraudster to be performed in your bank account. If the time difference is above some threshold, we are going to block the activity and send the user a verification to make sure
fine.
that.
Yeah, fine.
Okay.
So the kind of data set what you are using is time series data?
Yes.
Time series data. What kind of algorithms you are planning to use? Ontology,
Okay.
apart from that?
Hello?
So what kind of algorithms you are planning to use?
Okay, so since we haven't implement, but this is a knowledge based approach, we are going to see that if there is any approach for, because it is a rules that we are going to use. So, and we are going to see if the most efficient algorithm to use.
Okay.
Okay, fine, Ba.
Okay. Adamo, actually, thank you, Adamo. Try to
Okay,
incorporate the queries given by the session chairs. Okay.
Yes.
Can you? Is it possible to switch on your camera so that
Okay.
and also the session chairs so that we can take a snap?
Okay.
And also you just move to the first page of your presentation. First page of your presentation.
Okay.
Your presentation to first page.
Okay.
Thank you. Thank you. Thank you.
Okay, thank you.
Thank you, sir. Thank you, Sanjit Kumar sir and Gauri Ganesh sir. That's all, sir. Thank you.
Thank you, sir. Thank you.
Thank you, everyone. Our today's session getting over. Tomorrow we will be resume here at 9 o'clock in the same link. Thank you, everyone.
Okay,
thank you. Thank you.
Manimegala. Manimegala, இருக்கீங்களா? மணிமேகலை.
சார் கூப்பிடுறாரு, சுரேஷ் சார் கூப்பிடுறாரு.
சார் நீங்க லாக் அவுட் பண்ணுங்களேன். அவங்கள லாக் அவுட் பண்ண சொல்லுங்க. அவங்கள லீவ் பண்ண சொல்லிருங்க. இந்த
மேம்
மீட்டிங் விட்டு வெளியில வர சொல்லிருங்க.
மீட்டிங் விட்டு வெளியில வந்து சார் வந்துட்டாங்க சார்.
சரி.
இல்ல கூப்பிடல, மீட்டிங் விட்டு வெளியில வர சார்.